Okay, so we're in section 12.2 where you get to analyze arithmetic sequences in series. Arithmetic sequences in series are denoted by having what is called a common difference. Arithmetic has the term arithmetic in it, so the only way that it is an arithmetic sequence is each of the patterns have a certain addition or subtraction pattern with each of the values in the sequence. So if you can't, like what we talked about in section 12.1, if it doesn't have a one tier difference that's all the same, then it cannot be considered an arithmetic sequence. So here's, for example, we have some values in a sequence. We have, for example, A, we have 54, 43, 32, 21, 10, and negative 1. As we look at each of these values are subtracted by 11. 54 minus 11 is 43, 43 minus 11 is 32, 32 minus 11 is 21, so on and so forth. So yes, example A has a arithmetic sequence, and the common difference, which is denoted in D like we had in our on top of our table here in our notes, D would equal a negative 11. Now B, on the other hand, I have 4, 12, 36, 108, 32. Well, if I look at 12 minus 4, that's going to give me 8. And then if I take 12 plus 8, that's going to give me 20. It's not going to give me 36. So I can't uh, use this pattern as an arithmetic sequence, so this one is not an arithmetic sequence. So again, this is the rule for arithmetic sequences. This is the general equation. We have a sub n equals a sub 1, whatever the first value in our sequence is, plus d, which is the common difference, multiplied by the n minus 1, or the quantity n minus 1. So we're going to use that rule here to help us solve A and B. So my sequence here is I have negative 40, negative 25, negative 10, 5, and 20. So what I need to do first is find out what the common difference is. I can do that by taking, let's take negative 25 and subtract it by a negative 40. And from there I get a positive 15. So if I add negative 25 by 15, will I get negative 10? Yes, I will. Negative 10 plus 15, will that give me 5? Yes, it will. 5 plus 15, will that give me 20? Yes, it will. So my common difference here, my D is going to equal 15. So now all I have to do is put it into that equation and then find what the general equation is. And then also they want you to find what a sub 20 is. So let's look at the general equation. So I got a sub n here equals, okay, a sub 1. A sub 1 is the first value in our sequence, which happens to be negative 40. So I'm going to plug that in. And then it says plus our common difference, which happens to be d, and then it's going to be to the n minus 1 power. So that's the general equation that we're looking for. The second thing they wanted us to find was what a sub 20 is. So we can just go a sub 20 here equals negative 40 plus 15 times, well, n will now be 20. So 20 minus 1 is going to give me 19. And 19 times it by 15, it's going to give me 285. Add that by negative 40, I get 245. So a sub 20 is going to be the sequence pattern of 245. So now for B, I get to find the common difference. So I got negative 1 half, negative 1/4, 0, 1/4, 1/2, 3/4, go on. So if I take these two here and take a negative 1/2 and subtract it by a negative 1/2, I get a difference of a positive 1/4. So if I were to take negative 1/4 and add to 1/4, will I get 0? Yes, I would. 0 plus 1/4, I get 1/4? Yes, I would. 1/4 plus 1/4, is that 1/2? Yes, it is. So my D in this case is 1/4. So when I get to write my general equation, I got a sub n equals whatever a sub 1 is. So that's this value here, which is negative 1/2, plus the common difference, which is 1/4, times it by the quantity n minus 1. So that is the general equation for this particular sequence. And to find a sub 20, we do the exact same thing as we did in example A. We take negative 1/2, which is our a sub 1, plus 1/4, which is D, times it by n minus 1, which is going to give me 19. 19 times 1/4 is, what, 19/4. And then if I add that by negative 1/2, I get like 4 1/4 or 17/4 for my a sub 20. Okay. So there are some things that they're going to want us to find when we're identifying the general equation for the nth term of each of the sequence. Some of the problems they're going to give you just one value in the sequence, but they're going to give you the common difference. So what we have to do is plug those values into the general equation to find what a sub 1 is. And then once we find what a sub 1 is, then we can write the general equation, because let's write the general equation up here. So they give us the a sub n. We know that a sub 8 is 60, so I'm just going to write 60 equals a sub 1, which I don't know that, plus d, which is 9, times it by n minus 1. Well, they tell us that n is 8, so I can say 8 minus 1 is, which is going to give me 7. So from here, we're just going to use basic algebra to solve for a sub 1. So I got 60 equals a sub 1 plus 63. I subtract both sides by 63, which then makes my a sub 1 equals a negative 63. So from here, I can go a sub n equals our new a sub 1, which is negative 3, plus 9 to the n minus 1 power. Now, if you leave it like that, that's fine. But in the book, they actually distribute the 9 across, and then they solve it out. So I go a sub n equals negative 3 plus 9n minus 9. And then I got like terms here. So here a sub n equals negative 12 plus 9n. So if you have it like this, great. If you put it like this, that's fine as well. Looking at B, we're going to do the same thing. They give us a sub 12, so I'm going to write in 108 equals, I don't know what a sub 1 is, plus d, which happens to be 12, times it to the n minus 1. Well, n in this case is 12, so I'm going to say that this is going to be 11. So now here I get 108 equals a sub 1 plus 132. Subtract both sides by 132, so I get negative 24 equals a sub 1. So when I put a sub 1 into the general equation, I get a sub n equals negative 24 plus 12 times n minus 1. If I distribute my 12 out, I get negative 24 plus 12n minus 12. Combine my like terms, so this is going to be negative 36 plus 12n. Okay. Let's look at some others. We got this one here. Is we have to solve for 2 terms. So they give us a sub 6, and then they give us a sub 14. So what they don't give us is what a sub 1 is, and they don't tell us what the common difference is. So what we have to do now is put it into almost like a systems of linear equations problem with our general equation. So it looks like this. So let's look at a sub 14 first. So they tell us that a sub 14 is 79. So 79 equals whatever a sub 1 is plus d times it by the n minus 1. Well, this one happens to be 13, so we're going to add it to 13d. The next thing is let's put on the bottom, let's do a sub 6. So a sub 6 is 39, each equals a sub 1 plus n is 6, so it's going to be 5d. All right? So let's use the elimination uh, practice in order to solve for this. So if I subtract this equation here by this equation, so if I get 79 minus 39, that's going to give me 40. A sub 1 minus a sub 1 actually cancels out to be 0, and this is going to equal 13d minus 5d, which is going to give me 8d. So I get to divide both sides by 8, so my common difference is going to be 5. So now that I know what my common difference is, I can use one of these two sequence values to help me find what a sub 1 is, just like we did up top. So if we have, like, I'll use a sub 6. So let's go 39 equals a sub 1 plus, so it would be what, 5d for d, and then it's going to be to the n minus 1. So from here I go, well, actually n, I'm sorry, is n is also 5, so I'm going to say 5 times 5. So that gives me 39 equals a sub 1 plus 25. 39 minus 25 is going to give me 14 for my a sub 1. So I'm going to say a sub n in this case is going to equal 14, which is my new a sub 1, plus 5 times to the n minus 1. And if I distribute my 5, I get 14 plus 5n minus 5. 14 minus 5 gives me 9. So my general equation could be 9 plus 5n. Okay? Let's look at some sums of finite arithmetic series. So if they tell you where the series is going to start and where the series is going to end, I know we can use the sum by using this general equation, where s of n equals n times the quantity a plus 1 plus a plus 2 all divided by 2. So from here, I can go, all right, I have the sigma notation of I equals 1 to the negative 2 plus 4i over 28. So what we're going to do is this, is if I have my first value is going to be negative 2 plus 4 times 1, which is just 4, which is going to give me 2. And then if I find out what a sub 28 is, I can find what, hold on a second. Sorry about that. Here, this is what you, actually this is wrong. This needs to be a sub n, whatever n is. So if I look for s of 1 here, which is when I is 1, that's negative 2 plus 4, which equals 2. And then if I find what s of 28 is, it's going to be negative 2 plus 4 times 28, which is going to equal, let's see here, 4 times 28 gives me 112 plus a negative 2, which is 110. So if I wanted to find what s of 28 is in a sum sense, so I can say n, which is 28, times it by the first value, which would give me 2 plus 110, all divided by 2. So this would be what? 2 plus 110 is 112. 112 divided by 2 is 56. 56 times 28, which means that this series, when you add them together, is going to be 1,568. For B, first thing you do is you find the first value. So I got, let's look at when I equals 1. So it's going to be negative 5 plus 4, which is going to give me, what, a negative 1. And then I'm going to find when I is 8, which gives me negative 5 plus 4 times 8. So what, 32 minus 5, which equals 27. So if I want to find S of 8 in this case, times take N, which is 8, and then parentheses can be negative 1 plus 27 divided by 2. So negative 1 plus 27 gives me 26 divided by 2. 13 times 8, which gives me 104. So S of 8 in this case is going to be 104. And that is being able to analyze arithmetic sequences and series. Hope this helps. Until next time.